So the mean is 3.5, right?
Mm-hmm.
I'm opening here the homework.
So let's 7. I don't know.
Isn't that weird? I mean, this is something that I can email our instructor and ask him. But I'm just like, I mean, I'm positive that it's glaringly obvious, but that I'm just missing something. And so then on question 10, it says, what is the probability that the mean GPA for 81 randomly selected BYUI students is less than 3.3? But let's see, I have a spreadsheet for that. So 3.3 minus 3.5. 3.3 minus 3.5 divided by this is where we do the standard deviation divided by the square root of n, right? So this is, do we use the standard deviation in the problem, or do we use the standard deviation that we're not able to find?
That's a good question.
7, I'll try it both ways. 81. So that is negative 2.571. But then, oh my goodness. And it's asking for less than 0.0051. Oh, yeah, that one's right. So that one, you just use the regular standard deviation. So I'm still confused how they got 0.78 for a standard deviation, but that's fine. I mean, it is what it is. It's just weird.
Yeah, I'm not
and
sure what I'm talking about.
So then the next ones, I mean, they're pretty much, that's the problem that I'm having is on 15 and 16, it's asking, on 15 it says each shift 8 jugs of milk are randomly selected for thorough testing. The products are tested for filling volume, temperature, contamination, fat content, packaging, defects, label, placement, etc. Find the z-score corresponding to the sample mean volume. So I did, let's see. Where? So then, so the mean is 129. And we're wanting to know the sample mean for less than 28. So 128 minus the 29, right?
129?
Yeah, because that's the mean, right?
Yeah.
Okay, and then you're going to divide it by the standard deviation, which was 0.81. 8 divided by the square root of 8, right? Because that's how many they're testing. They're testing. 8 jugs of milk are randomly selected. Is that
Yeah, that's the sample size.
the sample size? Okay. 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 Let's see, what does it say? The products are tested. Okay. Find the z-score for the corresponding. So I've got negative 3.536.
That's your z-score.
Yeah, and that's okay. So that one was right. Negative 3.536. So, and then what is the probability that the sample mean volume for 8 jugs is below 128? So this one, you're going to put the negative 3.536 into the applet, right?
I think so.
Okay.
What was it?
Let's see.
Negative 3.
0.536. Oh, so yeah, and so then it gives me this weird number, and I'm like, I don't get it.
So that's for 16, right?
Yeah.
So it would be less than. So I think it would just be the.
Because the answer
That's
that they have is 0.0002, but that's not at all what I'm getting.
2.0312 e to the negative 4th.
2.03, is that what you said?
Yeah, and then it has the e to the negative 4. So that's 0.00002. However many zeros.
Oh, it is?
Yeah, I'm pretty sure.
Oh, see, I thought in order to do that, it had to have the point in front of the 2.
Maybe you're right. It's been a while since I've taken a math class.
I know it. That's why I'm like, oh, so that has to be the right answer, though, because I don't know how else you would get it.
And it's like small enough if you look at the graph. It's like super small. And so it would make sense.
Oh, and it's negative 4. So, yep, okay, so that is how you do it.
Yeah,
oh, yeah, because you type it in, if you put it up in the formula bar on Excel, it's, okay, yep, I was doing it right. Oh, that was so weird to me. They shouldn't throw those at us. That's so weird. So I don't get that first one, but I will email them, and then whatever I find out, I'll let you guys know.
Okay. Yeah, that would be good.
Okay. Okay, so thank you for your help. Do you want to get started on the quiz?
Yeah, Jeffrey emailed.
Sorry, did you find some answers for question 9 and 10 in the homework?
No, I'm going to email the instructor and find out for question 9, I think it was.
I found in 9, I don't know if I'm correct, 0.1.
Oh, well, they have the answers. You can check your answer. So yeah, go for it. What did you get?
Yeah, I get in question 9, 0.112.
That's not the answer they have.
I don't know if I'm correct. I just solved it now.
Let me see. On question 9?
Yes. Homework 7.
What did you get? Tell me one more time what you got.
Yes, I use the Z formula. No, for example, value minus mean divided by standard deviation. No, I use the information in the exercise in the beginning of the exercise. No, about the mean 8544 and standard deviation 12 gallons. No, and I apply the formula Z 8550 minus 8544 divided by 12 times square root of 20. No, because 20 is the end, no, of this question. I solved this formula and I got 0.112. Well, because the exercise is asking for the z-score, no, for the sample mean.
So on number 9, it's asking for the shape of the distribution, which is normal.
Yes.
And it's asking for what the mean is, and the mean is 3.5. And then it's asking for the standard deviation. But it says on the answer sheet, it says that the standard deviation is 0.078.
And not the, for example, 12? Because in the beginning of for example, use the following information to answer the next four question, no? So before question 7, we have some information, for example, mean and standard deviation. We cannot use this information in question 9.
Let's see. Yeah, no, that's not the answer that it's giving. So on the answer sheet, it says that the standard deviation is supposed to be 0.078. But that's all right. I'm gonna email him and just ask him to clarify that, because I don't get it.
Yeah, it's better. Okay.
Yeah, so perfect. All right. So chance to answer your 1 and 2 for the quiz.
Yep.
Yes, yes.
Okay, I will start with number 3. If I can find it. 1, 2, 3. Okay. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of the z-score 1.358 and to the left of z-score negative 1.358. Round your answer to 3 decimal places. So I put 58 negative in, and it's, let's see, and it's wanting the center of it, right? Or what did it say? It wanted the left and the right, huh?
Yeah, so everything but the center.
Okay, so I have 0.1745.
That's what I have, but rounded 0.175.
Yep. I got 176. Let me check. 176. Let me see. 1.1358.
So what did you get, Hannah? 174.174?
0.1745, but rounded 0.175.
Yes, 1745. 1745.
Yep, and then rounded it will be 0.175.
Yes, 0.175. Yes.
Perfect.
0.75. That's right.
Okay. Question 4. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from the population? Distribution of individual observations, X, distribution of sample means is cannot be given or determined with the information given. So it's wanting to know which will have the smaller standard deviation. Would it be the middle one, the distribution of the sample means? Or no?
Okay. Let's see.
Will be the second option.
Is that what you think as well, Danny?
Well, I really am kind of like, I don't know at all, because where the heck is it? I kind of can't visualize it. Let's see. will have a smaller standard deviation if 9 observations are randomly drawn from a population. So 9 is not a very big number, but that has to do with normal. I'm sorry, I'm trying to talk myself through this.
Okay, no
Distribution
problem.
The distribution of a sample mean. So probably, yeah, I'll go with the number 2 because that's going to be,
yes.
The sample mean is narrowing it down anyways.
Yes, for me, the option 2.
I'll go with that. It's either that or this can't be determined from the information given.
Yeah.
Because I'm kind of, the only reason why I'd be leaning towards that is because you really don't have a lot of information here to decide what your standard deviation is to even calculate it, to try and, so, but yeah, we can go with that. We can go with that.
Okay.
Yes.
I'm good with it.
So question number 2, no? The distribution of the sample means.
Yep, the answer, the second one, yep.
What I put it, yes.
Which of the following results implies that the spread in X bar decreases as the sample size increases? So I read through this and I'm a little confused. I don't think it's the rule, the 95, 99.7 rule. I don't think that has anything to do with the sample size. Kind of torn between the central limit theorem and the law of large number.
Yes. I guess it's the central limit theorem. I think so.
So here's the central limit theorem. Describes what happens to the shape of the distribution of sample means when the sample size is large. The law of large number describes what happens to the spread of the distribution of sample means when the sample size is large.
So the law of large numbers said that the spread?
I kind of think so, yeah.
That's what it sounded like.
Okay, good.
Okay. Use the following information to answer the next 4 questions. Scores in the quantitative portion.
So, sorry, what answer did you put on the question 5? Central limit theorem or
no,
the law?
We put the law of large numbers.
Okay.
Scores in the quantitative portion of the GRE are approximately normally distributed with mean mu equals 150.8 and standard deviation sigma equals 8.8. Question 6, Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? Round your answer to 3 decimal places. Okay, so I wants to know the z-score.
Okay.
So do we just do the formula for this one?
Yeah.
Okay.
It's not gonna open. Let's see. Oh, there it goes. Oh, stop it. Okay, so did you get 1.045?
Yes, me too.
Yes. So, okay, just to make sure I did it correctly. So you use the 160 for the square root, correct? At the bottom? Or no?
No, I did the square. Oh, no, because it's not asking for the sample mean.
Yes, yes.
it's just asking for the z-score.
Yes.
Oh.
So when it's got the word sample in it, then you do this, the divided by the standard deviation divided by the square root of the number. So this is just asking for the z-score, which would be the 160 minus the mean divided by the standard deviation.
Okay. Okay. So 160 minus the 150.8 divided by 8.8.
Uh-huh.
Yes. 1.045.
Okay.
Are you good, Hannah?
Yeah, just putting it in. Oh wait, is it the square root of?
For which one?
So it's 160 minus the 150.8 divided by the square root of sigma?
Nope, just the standard deviation, because this one is just asking just for that simple z-score.
Yes.
Okay,
So-
so 150 minus 150.8 is 9.2.
Divided by the
Divided by-
standard deviation, which is
Oh, okay.
the 8.8.
I kept typing in it, but I kept getting like a different number, like a big number, and I was like, okay, what am I doing? I just did it wrong. I got the number, so I don't know. Okay.
All these formulas are getting pretty confusing. So the only reason why I can keep the next z-score, the sample one, straight is because it has the word sample in it. And
So-
if they throw anything else at me, I'm going to be lost.
Okay, so the sample one is the square root. Sample.
The sample one is the square root. Yeah.
Okay. Yeah.
Okay.
The 1.045.
Yes.
Okay. So number 7. What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? So then we've got the z-score
Yes.
already from above. 1.045. 1.045. So I'm going to put that into my little thingamajig, and then I'm going to color in just the right side because it's above,
Yes.
and I get 0.148.
Yes. 148. That's right.
That's what I got.
Okay. 0.148. Okay.
Okay. A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, 153. What is the z-score corresponding to the sample mean of these students' scores? No. So, does it want us to find the mean first?
I kind of think so. I think we need that quantitative. Do you guys still have that quantitative spreadsheet? Is that quantitative, I should say?
Is that one of the links that we click on that they give us?
Yep, I have it right here. I can put it in if you want. I'll just share my screen.
Okay.
Let me just share it really fast. Okay, can you guys see my screen?
Oh, yeah, that one.
175, 163, 149, 153. Okay, so what is it asking? I can't even remember anymore. What is the z-score corresponding to the sample mean?
Yes. First, we need to find the mean. No?
Yeah, so the mean is 160. Okay, what is the sample mean of these scores?
It also, I don't know, couldn't just use the same formula because it gives us the standard deviation and we have the sample. Or no?
So, but what is this z-score? But what are we trying? I mean, what number are? What is the z-score? So the z-score, you have to have the something minus the mean of 160. So what are we minusing?
Just a question. Probably, do we need to find the mean between these 5 numbers?
Yeah,
160, 175, 16.
Yep, and that would be the, so we now have the mean and the standard deviation, but to find the z-score, we usually are taking something from, I mean, like something minus the mean, right?
Mm-hmm.
Because the x bar, no, is a mean, no?
The x bar is the value, right?
We have a sample of 5, no? So we need to find the mean between these 5 numbers, no? I got 160.
Uh-huh.
160 minus 150.8 divided by 8.8 times square root of 5.
Oh, yeah, because we're still on the last little thing. Oh my gosh, yes, you're absolutely right. Yes, thank you. Okay, so let me just, now that I have this, oh gosh, some days. So I have the standard. So we have the mean, but which standard deviation do we use then? I guess we'll just use the other one. So let's see here. Sorry, let me.
And the final answer, I got 0.468. The z-score.
0.468. Okay, so how did you get that? Because isn't it the mean is 160 minus, isn't the mean is 160? Wait.
Yes, I calculated a mean, no, between these 5 numbers, no. I got 160, 160.
Uh-huh.
And I use this number minus the mean of population, no, that is 150.8. And I divided this number by 8.8, that is the standard deviation, no?
Yeah.
Plus, times the square root of 5, because we have n equal 5 students.
Why? Yes. Why did I made that so much harder than it needed to be? Oh my goodness.
Because the z-score equals x bar minus mean divided by the standard deviation. Divided by square root of 5. Sorry, my calculation is not correct. Just a minute, please. I will redo my calculation.
So,
The square root
of 5. 25.
Yes.
But I have 25.715. I don't think that's right.
9.2.
I keep getting different answers every time I do it.
I know. So I did the 160 minus 1.
Yeah.
What was it?
That's the 9.2, 150.8.
I put the 160 minus 150.8 divided by, oh, that's my problem. 8.8 divided by the square root of 5, and I get 2.34. Just around it too. I get 2.338.
I got that one of the times I did it.
Okay, so do you see how I did that? I did the 160 minus 150.8, and then this is divided by, I have it separated out in 2 different things. So I have the 8.8 divided by the square root of 5.
Yes, that's right. That's right. I got 2.338, the z-score.
Perfect.
Okay.
Yes.
So
yikes.
2.338 rounded. 47.
We're supposed to round, what are we supposed to round it to? 3 decimal places, so 2.338.
Yes.
So I'm not feeling very confident about this quiz. Am I the only one?
It's definitely one of the rougher ones.
Yeah. Oh my goodness. Okay. So What? Do you want me? Are we ready for number 9? I don't even remember whose turn it is. I'm happy to do it.
Yeah, I'm ready. Do you want me to go, or did you want to go?
Oh, yeah. No, I mean, I can do it. It's all right.
Oh,
what is the probability, that 5 randomly selected students will have a mean score that is greater than the mean achieved by students in the previous problem?
Into 4 decimal places.
Okay. So, what is the probability of 5? Oh my gosh. Have a mean score that is greater than the mean achieved. So, okay, so it's asking what is the probability that they will have a mean score higher than 160? So, wouldn't we go back to our normal z-score with the 160 minus the 158.5 and plug in the 2.338?
Yes, on the normal
into the,
no? Yes.
I'm thinking so.
Yes.
2.338, and we want above that. So I got 0.0097.
That's right. That's correct. Yes.
So
4 decimal places. Yeah. 0097. Yes.
do they want to? Is it just that, or do they want the percentage as well? Just that then.
0097. That's.
I think so. Yeah. I feel like, have you ever tripped and then you just keep running to try and keep yourself upright instead of falling down and just letting? That's what I feel like this quiz is doing. We're like tripping and falling, we're stumbling and just trying to keep ourselves upright.
Mm-hmm. Yeah.
Sorry, that's my metaphor for this quiz.
It works. Use the following information to answer the next 5 questions. Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that the distribution is left skewed. A random sample of n equals 81 students will be drawn. Oh, of n equals students. Okay. Question 10. What is the shape of the sampling distribution of the random variable x bar, which represents the sample mean of the 81 students who are selected? Okay, so I just want to know the shape. Like these always confuse me because they say like it is well known that the distribution is less skewed.
So look at your sample size.
Yes, 81, no, higher than 30, no?
Yep.
Yeah.
So maybe approximately normal.
This is where you're going to be approximately normal.
Yes, that's right.
Okay. Why this always confuse me?
So if your sample size were to be like, say, 4, then I would put that it would be less skewed. It would match the distribution, the parent distribution. But since the sample size is so large, then it forces it to approximately be normal.
So when does it become right skewed?
When it says to be right skewed. So this is just to throw you off, because if it said that, if up here it said that it was right skewed and the sample size was teeny tiny, then you'd pick right skewed.
Oh, okay.
But up here, I mean, and as far as I know, it doesn't have any indication. There would be no evidence that would say that it would be right skewed. It would either only be left skewed or approximately normal.
Okay.
That's right.
Approximately normal when it's over 30, right? Is that the number?
Mm-hmm. Yeah. Okay. What is the mean of the distribution of the sample means for all possible sample sizes, size 81, that could be drawn from the parent population? Okay. So let's see here. Let's first do
the z-score.
Yeah, let's do the z-score, which is, well, what's it asking for? What is the mean of the distribution of sample size? 81. So we're wanting 81. But this is where they confuse me. all possible.
What is the meaning of the distribution of the sample means?
Oh, this would be, because it's normal, it would be 3.5, right?
3.5?
Yeah.
Why?
Because it's normal, and so it follows the normal mean. This is where that what's it called? Let me try and find it really fast.
Oh, yes, that's right. That's correct. That's correct. Yes.
Okay,
3.5.
why? We are making this so much harder than it has to be. I promise you.
That's correct.
Goodness. I'm glad we're all in this together.
Yes. In the standard deviation.
I feel bad for those that. Yeah, I feel bad for those that are going to watch this video. They're going to be like, please, come on, you know this.
Do you think other people watch it besides the professor?
I have no idea, but I feel bad for them if they are.
Sorry to those who are watching.
Right? All right. Question 12.
What
I need to.
Go
ahead. I just need to plug in my computer, so go for it.
What is the standard deviation of the distribution of the slipper means?
0.7 divided by square root of 81.
Draw possible samples of size.
0.07777.
7 is the standard deviation. What was the first?
I found 0.078.
Okay. What is the standard deviation of distribution?
Yes. We need to use 0.7 divided by square root of 81.
0.07778.
Yes.
Does that sound right to you, Danny?
What is the standard deviation?
Yes, the formula of standard deviation in this situation. No, we need to take the 0.7, that is the standard deviation in the beginning of problem, and we need to divide this number by square root of 81.
Okay.
I got 0.078.
Standard deviation, yeah, yep, perfect. Can you guys see my screen?
Mm-hmm.
Okay, the standard deviation of a sample mean is the standard deviation divided by the number, the square root of the number.
Yeah, that's what I did, no?
Yep.
Yes,
and
that's correct. That's correct.
How many do we round it to? 3? 4?
Yeah.
Yes.
So it's 0.0778.
Yes, but three decimal places, no?
Yeah,
0.078. Sorry.
Yeah, that's correct.
Okay. What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3? Okay, so the regular mean is
We need to find the z-score first, no?
3.5.
Yeah.
Yep, so it's 3.3 minus 3.5.
That's correct.
Divided by the 0.7 divided by the square root of 81, right?
Yes, at 0.078, no? We found in
Yep, and so the z-score is going to be negative 2.571.
571? Yes.
And what's it asking? What is the probability? So we're going to put that negative 2.571. And we're asking for less than, right?
Yes.
So I have 0.0051.
Just a minute, please. Less than, no? So
If we're doing less than.
what did you find? 0.00767?
No, I have 0.0051 because I have
0.34. What number did you use in the z-score?
on the z-score. I put 3.3 minus 3.5 divided by 0.7 divided by the square root of 81.
I see. Divided by 0 by the square root 81. Yes, 57, no? 2 minus 2.57, right?
Yep, my negative 2.571.
Yes, 571. That's correct. 571.
And
yes.
So I put that in the normal probability app, and then I color that left section, that left side blue.
Yes.
And it gives me an area of 0.0051.
51. Yes.
Correct.
So it would, it's 3 decimal
places. 0.005, no? 2 decimal places, only 0.005.
Correct.
Okay. What is the probability that the mean GPA for 81 randomly selected DPYU students will be greater than 3.3? So we just highlight the other side.
It's the same.
0.9949?
Nope, you just color in the right side.
And it's 0.005.
Yes, what the right side, no?
Yep, so it's going to be exactly the same.
Yes, that's the same.
Okay.
Okay. The United States Coast Guard assumes the mean weight of passengers in a commercial boat is 185 pounds. The previous value was lower, but was raised after a tragic boat accident. The standard deviation of passenger weight is 26.7 pounds. The weight of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more, either above or below the mean, than was observed in the sample. Round your answer 3 decimal places. Note as extreme or more extreme means that we are not only interested in values that are lower than the ones we observe, but also values that are as far away from the mean as ours in a positive direction. What?
So let's know the probability.
So let's find the z-score first. Yeah?
Yes, so the sample mean is 177.6 minus 185.
Divided by 26.7 divided by square root of 48.
The standard deviation is 26.7.
Z-score minus 1.92. Z-score?
Negative 1.920. That's what I got for a z-score.
Yes.
Find the probability that a random sample passenger will have a weight that is as extreme or more extreme, either above or below, than was observed in this sample. I'm kind of confused by that. We are not only interested in values that are lower. So is this where we're going to go between? Like the, that doesn't make sense either.
On the highlighting, you mean? Okay.
Extreme or more extreme.
So, but do we add those two together?
Well, it sounds like it. It sounds like they want either or. Like both.
Yeah, maybe between and yes.
We put like negative 1.920.
Yes.
And then shade in both the right and the left.
Yeah, I got 0.0549.
That's what I got, 0.0549.
Yes, yeah, 0.549, no?
Yep, so 0.549.
Is that what we want to put?
That's what I don't know how else to do it. That's so weird.
It's weird the way they worded it.
I know. Let me just see something really fast.
So are you agree with the answer? Because
yes.
0.055. Because here, for example, in the note in the question number 15, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are as far away from the mean as ours in the positive direction.
Okay. Yep, I think so. Let me just see what is the what. I think we did number 14 wrong.
Sorry?
I think we did number 14 wrong. What is the probability? Let's see.
Only 14? Only 14 wrong in you?
I think that we have 14 wrong. I haven't submitted it yet.
Why do you think we did?
What is? Because I don't know. We can submit it.
Let's go.
All right, we can submit it.
So what did you put in the question 15?
0.0549.
Okay, so only 3 decimal places, 0.055. Correct?
We're only supposed to go 3. 1, 2, 0.055. Yeah. Gosh, I hate that.
Guys, we did a good job.
Let's go.
We did?
Yes, I'm submitting.
I'm submitting right
I'm gonna
now.
laugh at which one we got wrong.
Let's go.
Probably number 1 or 2.
No, it was question 14.
Ah, I knew it because I kind of think it's supposed to be.
Only 14. Yes.
What do you think it's supposed to be?
What is the probability that the mean GPA for 81 randomly selected students will be greater than 3.3?
We should have highlighted the
Yes.
middle and the right side.
Yes.
What is the Z-score in the question 14?
I have to put it back in. I don't know off the top of my head.
What did we have it as?
I put 0.25, but that was just the one side.
What was it? 0.005?
That was just the right side highlighted.
And we need to put,
I think it was supposed to be 0.99.
sorry, what did you put? 0.9?
What was the Z-score for that problem again?
I don't know. I can't remember. Let me try and find it.
What is your final answer for question 14?
We haven't figured it out.
We don't know yet.
Okay.
Let's see. Let me go back to the quiz. Let's see. So it was 3.3 minus 3.5. 3.3 minus 3.5. And the standard deviation was 0.7? I can't remember.
I think it was
0.7.
Oh, really?
Yeah, it was the standard deviation was 0.7 and the number was 81.
Oh, right.
The Z-score minus 2.571.
Negative 2.571. So if you put that, oh no, negative
71. So if we want higher than, probably 0.995.
0.995.
Yes, that's what I think about.
Do we want to redo the quiz?
Yes, let's go. Let me note the answers here. Let me
get a piece of paper really fast so I can write down the answers. Four, two,
Okay, I'm ready when you are.
Okay, I'm ready. Let's see here. Let me just get it.
Okay. Question 1, true. Question 2, true. Question 3, 0.
Oh, I'm starting the wrong quiz. Hang on just a second.
Yes, 5. correct.
Okay.
I guess I'm question 6
1
now.
is true. 2 is true. 3 was 0.175, right?
Yes, yes.
4 is the distribution of sample means X.
Yes, you know, yes. Question number 5, the law of large numbers. Question
Yes.
6, 1.045.
Oh, question 6 is 1.0. Oh my gosh. 0.045.
Yes. Question 7 now.
7.148.
Yes, that's correct. Question 8, 2.338, correct?
Yep.
Yes. Question 9, 0.0097.
Correct.
On 10,
Approximately normal.
Yes. Question 11, 3.5.
Yep.
Question 12 now. The question is 0.078.
Correct.
Question 13, 0.005.
0.005, right, for 13?
Yes, 13, that's right.
Okay.
And 14, 0.995. Correct?
Correct.
And the last one is 0.055.
Okay.
Okay, let's submit. Yes. Perfect.
We fixed it?
Yes, we got it.
Oh, finally. That thing was a bugger.
Okay, congratulations, group.
Congratulations. It looks like we lost Hannah, so I hope that she...
Oh, yes.
Oh, here she is. I'll stick by and help her.
Yes, yes. So thank you very much for your time. I think you did.
Yeah.
A good job.
Thanks, Ronaldo. We'll see you next week.
See you. Have
See
a
you.
good weekend. Okay.
Yeah.
See you.